going. Sorry for a slight delay, but we had an active discussion in office hours. So I hope everybody has at least started looking at their homework. Like open it up, saying, hello, homework. What am I up against? So it's not a bad idea to stop by office hours, even if you're kind of, the best use of your time and office hours time is that if you actually look at it, form questions, and then come into the office hours. That's just the best value. However, if you haven't done that, it's not a bad idea just to stop by and see other people asking questions so that you can figure out what you're up against and what might be your questions, right? So when you get to it and start working on it, you might then, you might actually be better off. So something to think about. Without further ado, we're going to actually now introduce a topic that you have been actually introduced to. You just didn't know how to do it yourself. And that's the topic of functions. So I'm going to go over a little bit of like just what is the logic behind it, and then of course we'll just jump in and do it by example. So let's get going. Let me just, all right. Make sure that I think I did start recording, so that's good. So most of the time now, whether we were working in Spider at the very beginning, or the notebooks that we kind of prefer for their visual look, and also outputting the result in the homework, we have just like been typing commands. Okay? And often you have a parameter somewhere, so in your homework you're going to be implementing an algorithm to calculate a square root. Okay? And we ask you to use 3 values and do it for 3 values in the homework itself. Right? But if you're going to repeat something for different values, and tomorrow you might come in and want to do something else with that, with different values, square root of some other number, then it might be a good idea to package that piece of code so that you can execute it always for this new value that you'd like to, and it gives you certain results. And that's something what you've been already doing, so using np.square-root, sqrt, is going to do precisely that. You give it a value, it's going to give you a value back that is approximate square root. So, but you don't know and you haven't seen what np.sqrt looks like, have you? Python is open source, so you actually can go and find it, and you will probably find the code that is a little hard to read because it has all the possible cases that could blow up programmed inside. So it may be a little unwieldy, but you can actually access and see what it does, but as long as it actually calculates square root, you want to move on with your life and do something with that square root, right? So often you will actually rely on pieces of code that other people have put together. Hopefully you will test it a couple of times, and then you will just use it. So we will today learn how to do just that. You will probably not be busy doing square root as your assignment in your professional life. You will use square root programmed by somebody else, but you will have something else as a task, and you want to package it for other people to easily use or for yourself to repeatedly use. Okay? And that's the point of functions. So we have already used built-in functions, and they typically require some input. Sometimes they work without input, but some input. And then they give you something back. Okay? So basically the way it works is you throw in certain number of input parameters, we kind of divide them by comma, into a function. Function does something and gives us something out. Okay? That's the base idea. Now we need a syntax that actually is going to execute that for us. So once we have that piece of program, you will be able to use it as a function. All right. So basically, the way you do it, you have to first declare or tell Python, hey, function is coming. Okay? And you do that with a so-called reserved word, def, defined. define. What follows is the name of the function. How are you going to call this function by name? We all have names and people call us by names. Okay. And just like you might or might not like your parents giving you the name they did, that's what you're going to be called for better or worse, right? So take some care in naming your function. Make sure that the name sort of is short enough, but it reflects how is function going to be used and what for, okay? And then there are input parameters, and our infamous colon. Colon always tells Python, hey, there's a block of statements that is going to be executed for this particular case. And in case of a function, what it's going to do is this function will take these input parameters, and you will give it parameters that are actually, say, 3 and 4. But for the case, for the purpose of this block of statements, I'm going to refer to them in general as A and B. Okay? And then the rest of this basically depends on A and B in some way, works with A and B in some way, whatever makes sense for your piece of code. And then you return something. And if there's more of something, you just keep with commas what you want to return. So things come into the function, input, and come out of the function. Yes? Output. Input, do something, output. Okay. And we can actually then execute this function and get that output. Let's give it a try. Okay. So I'm gonna, oops, I need to restart my Anaconda. So open up your Anaconda/Jupyter. It might be already open. If it is open, give yourself a new script that deals with functions. So I'm going to navigate to my So I'm going to do a new notebook. So let's define this function. I'm going to call it a plus that works with A and B and colon. So again, define tells Python function is coming. You could do this anywhere in the code. And then there's this sum that I'm going to refer to as S, that is A plus B. And I'm going to simply return it. So this block of statements works with input A and B. Okay? And returns whatever result. So now if I want to use this function, I can say plus, let's see whether this just in itself, whether it works, 3 and 4. The question of the day is it going to print the result? It actually does. So this is the output that didn't go anywhere and it just got printed on the screen, which is not guaranteed. But it did. If I do 40 instead, I'm going to get 43. Okay. Yes?
What does the return
That means take the value that you computed and return. A and B are not returned as values, so unless I store them in some way, I don't have access to them. So excellent point. Let's return a value, C equals 2, or without working with it. Let's try to, so this works with some S, right? Let's print S. What happened here? Name S is not defined. What about A? Same thing. B. Give it a try on your computer. So outside of the function did actually return a result. I didn't save this result, it's just printed for me. My brain saved it, but computer didn't. Okay? But neither A, B, nor S are accessible outside of the function. Function cleans up after itself. It does what it does, returns only the result out. If you don't save it, well, too bad. It's printed for you. Your brain can save it. The computer didn't. That's it. Which is good. Okay? I compared that to my kitchen. Okay? When I close the door of my kitchen, whatever mess happened in my kitchen stays in my kitchen. Guests don't see it. And trust me, there's a lot of mess. So in that sense, once you close the door, you don't want to let the mess go out, which is also good for cleanliness of the coding. So if I actually want access to, or anything that I want to access to, okay, I need to actually save it. And what I save it outside, so outside of this function, I didn't talk about A and B. So outside of the function, I don't know what A and B is. And that makes sense, because if you were using Python function, np square root, right, sqrt, whatever it defines inside to calculate that square root, you don't know about. You don't know what is it calling things, all of the variables that it needs to actually do an approximation of that root, which you're actually going to try out in your homework. You don't want to know. It should, it should calculate what it needs, create the variables that it needs temporarily, and then just give you the result. Moving on. So what happens in function stays in function, just like Las Vegas, okay? Unless you actually returns back with you home. Please don't do that, okay? So, might be illegal. All right, so basically, if you want that result, you save it. I can save it in some different name, C, that only I know because I'm using the function, right? I don't know what is function calling this result, and I don't care. It's calling it S, who cares? I don't often see that code, okay? And now I can actually, I can print C. Oops, I need to execute the cell before that. And then I can print C. Yeah? Okay. Now, what if we also want a product? A times B. Okay. So, will I know about this product outside of the function? So it did get computed, but I didn't make note of it. I didn't return it. You worked on it, but too bad. Okay? You might have worked on your homework, but unless you submit it, it's not going to get counted. Okay? So to get it counted, you can actually say, hey, return both. And to catch both on the outside, you give it some outside name. Okay? And then we can print both. Again, I'm doing it in a different cell without executing. How about I just do everything at once? Here we go. So names of the variables inside the function, only kind of function or the person, author of the function knows. That author returns something out, and that's the only thing that is saved, but it's saved under the name that the user wants. The user wants to call them CD because that's what makes sense. Nothing makes sense in naming here. A, B, C, D is just what I come up with, right? But it's whatever I want right now. What can be a function? Anything. So I could go now down the list of stuff we did last Monday, okay, and make a function out of each and every thing. Okay? So you will often start writing a code just to see that code is correct. You will write a piece of code, you will check that it works, and then you kind of package it into a function afterwards. Right? After you used it and polished it a little and figure out how you want to use it, right? So there's no mandate that you make functions unless we ask you specifically on the exam, write the functions so that does this and that. Right? So there's no mandate to make functions. It's just that they make code reusable. And reuse is very important in coding. Doing something all over again doesn't make sense. And again, point of your existence is not calculating square root. We're just practicing with it. But after that, you're just going to want to use whatever NumPy or SciPy or you name it came up with as square root. And you will want to do something else with it. Okay? We're just teaching you mechanics of how to do it for your own application. And maybe we're using some sort of common calculus things to do that. But at the same time, like, you want to actually spend time designing your own and then letting somebody else use them. So let's grab actually, I am literally going to grab a piece of code. Which one though? There's those sums. Was there a sum? Okay. There was a matrix, and we were computing sum and product of all of the elements in the matrix. This was a very specific matrix, okay? We will likely, if we want to make a function, we will want to do it so that it can be done for any matrix, okay? But first things first, I will grab a piece of code defining a matrix. So it was a 3x4 matrix, right? So I'm going to grab this piece of code. I'm copying it from my previous exercise. And this was working with a random function, random matrix A. Here we go. Okay. So this was code that creates a function, a matrix 3x4, and computes sum and product of all of its elements. And let's just test that that code works. I had that weird break. I'm gonna just remove that break because that's not what I Okay, so these are sums by row, which I may or may not choose to print. Okay. So the code went for all rows of A. Okay. Then go and for all columns in every row, keep adding elements and also keep multiplying them. And I initialized sum as 0 and product as P. So how do I now, everybody has this code from Monday-ish, if not, you can retype it quickly. This S by row is irrelevant, so we may as well get rid of it. That was just playing with it last time. Okay? So this is my essential code that goes over all elements of a 3x4 matrix. So let's say I want to create a function out of this that would work for some matrix A of whatever size. Whatever size. Okay? What would be input to my function? Dimensions could be the input, yes. And matrix itself. And output would be S&P, because you already have a code working. Okay? So let's step 1. I'm going to actually copy this exact code that was working, so I don't want to copy it into next cell, and I'm going to convert this to a function. Input, so I'm going to design that input is my matrix A, yes? And my sizes, let's refer to them as M and N. So this is matrix. And sizes, so these are dimensions. And what should the output be based on this? What should the output be? What am I computing? I'm computing sum of all elements and product of all of elements. So how about those being an output? Okay? Output S and P. Your first task, and I'm converting the code, so I'm going to examine. So first, you kind of write yourself a code that does the function you want to do it, okay, on an example. So here I have an example A, and it's computing, and I hopefully did the little test of figuring out that it works correctly, right? After this, I want to package it so that I can use it easily and in a more general case. Writing a general code immediately, it's typically difficult. We work better by example. Okay, so this small 3x4 example is a better thing to start from than actually designing, unless you've done similar cases, so you can just go. Okay. So first thing is so NumPy I certainly need, okay? But I want to define a function. How do I define a function? What do I write? DEF, and then I need a name of the function. What do I want this function to be named? Matrix, sum, product. How about that? Something that kind of summarizes what I'm doing. It's up to me. More meaningful names, the better. but not too long, because you gotta, when you're using it, you gotta type it in. Okay? What is input? What does first line still miss here? What is it missing? Colon. So this is your first 2 to 5 points in the problem that I'm grading, depending on how difficult the task is. Have you defined your function correctly? First line. Has to have the keyword, reserved word, DEF, name, inputs, and then colon. And inputs as specified in whatever task I'm giving to you. If you're designing on your own, then whatever you decided to be input. Okay. After colon, for all of the statements that belong to that function, what do I need to do? Four spaces indent, always. Otherwise, it doesn't belong to that function, or if statement, or whatever else that has a colon. Okay? So if you have a colon, whatever is the sequence of statements to be followed through, okay, it has to be indented for. So I'm just going to highlight all of the code below. And indent. Now all of this code, I don't know whether it's correct, but it belongs to this function. Okay? And before I start checking what's inside and whether it makes sense, I want to return. And I already have code that computes this sum and if it's red, it's telling me you're not indenting correctly. See this? Red, 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 green. What am I returning as an output of this function? S and P. Okay. So quite frankly, whenever you're coding and you're creating a function, first step is to, if you're coding on your computer, create a working little example that does what you need it to do. And then when you're creating a function, start with the shell. Define the first line, define the function correctly with correct inputs, decide what inputs will be, and decide what outputs will be, and put that frame there. Okay? Now let's correct what's inside. Here is a common problem, or one of the most common problems, when you're working in this stepwise, is that I had this line that has given me an example, a 3x4 example. Okay. If I do this here, this 3x4 example, I'm going to overwrite input that comes in the function. And I'm always going to have this 3x4 matrix instead of whatever I'm giving the function. Okay? So I want functions to work with the input that user gives them, that changes. Okay? This is a hard-coded A, so if you leave it there, then A is always going to be a result of this random function. It's going to be different because rand gives you a different result. When you execute it multiple times in a row, you're going to get slightly different results. It kind of draws from a distribution of random variables. More on that in geostatistics. Anyway, back to this. So I got to remove this. Nothing wrong with just commenting it for now. Okay? But be careful not to hard code and overwrite input. Do not overwrite input. And that's so important that I'm going to write it down. Do not overwrite input. Sum and product, I do have to initialize. That is all fine. And now I'm going over all rows of A. Is my A always of size 3? No. What is the number of rows of A based on the input that or how I decided to call it? So when I'm using this function, whatever I place, I will place here possibly a number 3, okay? Whatever I'm using or put here will be interpreted as number of rows, okay? And that's what I'm working with. So as my input changes, so does this for loop. It kind of changes dynamically. That's what you want in a function. You want function to dynamically adapt to the input. This was that S by row that is not necessary in this exercise. And then for J in range of 4, does this, every A, does it have 4 columns? How many does it have? N. Does everything else actually work? For whatever A I give it that is of size M by N? It does. Let's see whether Python complains. It doesn't complain. That doesn't mean that everything is working correctly, but step 1 is syntax is correct. Now I'm going to take my example from here. Okay. And now I'm going to execute this function with this example outside of the function. So note, we are now outside of the function. I'm not within the block, indented block. So only indented block belongs to the function. Okay. So we're now outside of the function. How do I execute this function? Call me by name. Has anybody seen that movie or read the book? That book, Call Me by Name, happens to be my summer reading for the past summer. Sorry. There's a book and a movie. Anyway, matrix sum product. And this is supposedly how am I supposed to use it. Is that going to work? Apparently not. Right? It says it doesn't know M. Because it doesn't know M, M and N is what I call them inside that function. So outside of the function, I don't know about it. I got to actually put a concrete value, which in this case is 3 by 4. Apparently calculated to two things. Can I now say, hey, print me that S sum? No. Oh, it knows it. It knows it from my previous example. It's actually going to work. Did you catch that? This cell has S and P. So it actually knows what S and P is. But it's always going to be whatever it was up there. So this particular sum, I would actually have to basically and I can refer to it as S and P outside. But it's not the same S and P that it uses inside of the block. I can call it whatever I call it outside. And then I'm going to catch those values. And I can print them. Well, or just both of them at the same time. And they will slightly change because my random function has slightly changed that function. That matrix A. Questions? There's quite a bit of.
For the last line. You have to do 3 and 4 for
The way I programmed, yes. Okay. Because, so if I don't, it's gonna yell at me and say it's missing 2 required positional arguments. So I define the function to have those. How do I go around that? Excellent question. Because frankly, why am I retyping it? Does my Python know what the size of the NP array is? Yes, how do we inspect it? With shape. So that information actually already travels with A. That's how NumPy array works. So let's change that. So this is now my code iteration number 2. Right? And this is how it happens. Your first time around writing a code, it's going to be a mess. They're going to keep fixing. And then as you use it, you'll be like, well, can I make this better? And you will make it better. So it's always an iterative process. Okay? So let's make it better. Okay? I'm going to work with the same. I'm going to remove dimensions as input. So if I just say a shape, will that work? I still need them as m, n. Let's see. Doesn't complain. So basically, shape returns those 2 values, and I'm grabbing them. I'm taking them as an output of function shape. And there's also np.shape as a function. This just actually immediately applies shape function to array A. So it's just an alternative way. It kind of travels with that array, or knowledge of the shape function travels with it. Excellent. So now I actually have, that's it, right? So I can now just work with this and print the result. And what's great about this design, my new design 2.0, is that I can just change this to 30, 40, and I change it only once. I don't have to retype it in the second one. Because if I did, it would work with 3 and 4 as long as my matrix is large enough to accommodate 3 and 4. It would just do 3 and 4, right? Do you have a 0 in your matrix? Print your matrix. So this one, especially when I have 30 and 40, random returns values between 0 and 1. This is now 1,200 values between 0 and 1. This is going to get really small really soon. And it simply gets below what we can store in a computer. Okay? And then your product is at some point just 0. Okay? We're going to get to that in the next lecture. Right. You could also do some other, if you just say one output or catch one output of this function. Let's see, what is this z? So this z is now a list of values, okay? So if you specify only one output value that grabs whatever comes out of the function, and function actually returns multiple ones, they're going to be returned as a list, okay? And the way you would get them is z of 0 and z of 1. Okay? So in this version, if only one output value is specified, but function
gives back multiple values. This output will be a list of those values. Does that make sense? It's just going to package it all. Yes. 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 There is. Actually, there's nothing forcing me really to have input. What did I do here? I created a function named, what's the name of the function?
Greeting.
Greeting. What are the inputs? None. Okay? No inputs. My syntax is followed with no inputs. Zero input is an input, or no inputs is an input. Okay? And then I'm just printing hello and returning nothing. What I'll do is just say greeting. Yeah. Now, what could I do here to create an optional input? So say that I want a function that will take the A if I give it A, but otherwise it will assume values. And I'm actually going to do that with a slightly simpler function from above, this one. I'm going to copy it down. I can just give it a default value. Definition seems to work. Let's now run plus. Oops, without inputs. I didn't provide any input, but in my function definition, I specified values to be used as default if I didn't provide any input. So option number one, okay, is you don't have to have input, you just do something in return. Okay? Option number two is you can actually define some test values in there that the function can work with and test your function without constantly typing in that input. Right? It's going to work with those values. If you don't provide anything, okay? Here, I could have actually said plus 4. What did it do? Set A as 4, and the B just took what I gave it, which is 4. I can't flip that. First come, first serve. Yeah?
You did a column before the 4, did it override B?
Let's try. Yeah. If I, here, 5? B, it doesn't, you can do, but no, logically what it does here is just takes that and sends its input, and it just goes by sequentially, right? So it's not going to recognize B here as the B you have, because you could have a B, and you don't necessarily know that inside function plus it's called B. Does that make sense? Because you don't know. For all of the NumPy functions that you've been using, you have no idea what those inputs are called inside the function. And you shouldn't, right? You just need to know how to use it. So because of that, you can't necessarily just do that.
So like
But this also, it doesn't like the assignment as part of the input. Input is a list. Okay, it's a list of parameters. So this is oops. So this should be. So this is not gonna work. Okay. So this input is treated as a list of values, and this is. You can do this, but it takes that as part of the definition. Okay. So I'm gonna just type yourself a note. 3 and 4 are default values.